Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. So I'm going to do some work on this because I want to have this thing with an internal battery pack. And because of that, I need to figure out how to do that. I've got no information about how the battery pack goes, voltages, anything like that. So I've got to try and figure it out as I go. Now, I've already stuck this thing on diode testing, or sounder, and I've already determined that the left two pins are linked together on that header there, JP2. I think it's called JP2, I don't know, but might be a wire in there. But those two are linked together. Those two there are linked together, right? So I've got here on the piece of paper. Hopefully you can see that. Hopefully the light's not too bright. There's a link on each one. So there's effectively a 3-terminal connector here. The middle one is already 0 volts. I've already determined that. So I'm just going to go through and look at the voltages and power it up. And we'll see what voltage you actually get there. I did look at this yesterday, but I want to make notes of it because it's got a low voltage indicator on here for the battery. So I also want to measure when that indicator comes on to say when the battery is low. So that way I know what voltage range it can work within. But because there's two connections here with different voltages on, I need to figure out exactly how that works. I'm going to actually substitute for my bench power supply a couple of voltages on there and try and work out what actually requires. Okay, so middle pin is ground, so stick that on there, and that pin there, that's 10.6 volts, 10.7 volts. That's with 110 volts going in. Put it up slightly higher. And we'll check it again. See if it's changed. It probably will. Yeah, there we go. So it's gone up slightly. Get it on there again. 11.7. Right, so yeah, that's at 120 volts in, I think. Well, based on what's on my Variac supply, stick it exactly 120, I think, and then go from there. It's probably going to be 12 volts. Yeah, 12 volts, 120 volts going in. Okay, so 12 volts there. We'll call that normal. 12 volt. Let's try the other side. $18 volts. So 12 volt and 18 volt. Okay. The dual supply thing is quite interesting. I'm actually surprised by that. I would have thought they would have like a main regulator which then drops it down again for the secondary supply. So I'm quite surprised by the whole dual regulator thing. Alright, so those are normal voltages, 12 and 18. Those make sense. Those are nice round numbers, so I think they're right. So let's drop this voltage down and I'll wait and see what happens when I get the indicator on the front here, which will flash the power light there. You probably can't see very well because of the lighting, but that'll start flashing when it gets down a bit, down to the voltage level where it thinks the battery's going flat. So I'm going to slowly drop the Variac down. There we go, started flashing. Let's bring it back up to it stops, and down just a fraction till it starts again. There we go, right there. Right. So that's like the warning. Normally gives you about 10 minutes or something. Then it's flat after that. So let's see what this voltage is now. That's 80 volts AC coming in. And we have there, get a good connection to be good, 6.8 volts. Okay, and that side 11.4. So 6.8 and 11.4. Right, so now we know that that's the range. It has to be at least above 7 volts on that one and above 12 volts on that one. Okay, so now what I'm going to do is disconnect the AC, hook up my bench supply. Let's just get it preset so it's going to do what I want, and then I want to figure out which supply it needs, which one is the important one, and stuff like that. And I'll try and figure out which one actually triggers that low voltage warning. So I'm going to start off with the main supply rails coming in, same as we measured here. Okay, so that's 12 and 18. So you've got a common ground. I think I might have to stick some header wire up to there or something. The other advantage is I'll be able to see what current it draws. That's half an amp on each, which is a little bit safer. So it should current limit if it's a problem. Okay. Okay, the 12 volt supply is current limited. It's almost there, so it's only just slightly too low. Let's go 1 amp on that then. Yep, it's drawing 600 milliamps on the 12 volt supply and 170 milliamps on the 18 volt supply. So it's not actually that bad. Still quite a bit of a call for a battery though. Let's stick the microphone in this and see what's going on. This is actually picking up the common mode noise in here. It's got a 50 Hz spike. It's picking up all the common mode noise that's floating through the air. Now I'll show you. See it? 50 Hz. Anyway, I've actually, did I buy it? No, I want to buy another one of these microphones. It has a response, but when I've done some basic testing on my audio system here on my computer, which I use for doing music, and the response has got a massive dip in it. It's like 20 dB dip. It's like, well, there's no way. So I think this microphone's probably damaged. Anyway, I'm digressing slightly. So at least the current's not too bad there. Now let's try and drip down one supply at a time and see which one makes this thing flash the LED, or makes it stop working, or something like that. So let's bring this up. It's been lots of rumble and noise and stuff here. I think it might be partially RF noise, I'm not entirely sure. Anyway, alright, let's drop down supply number 2 first. It's 14 volts, 13, 11 volts, 10, 9, 6, still going. Oh, there we go. 6 has dropped off. But I see LEDs dim. They need about at least 8 volts in that supply. Otherwise LEDs go dim. Okay, but that didn't start flashing and the other stuff seemed to carry on working. Right, here you go, you can probably see it better. So that's at 13 volts now, so I'll leave it there. When I did this test before, it was 11.4 volts is where it stopped. Let's try the other supply rail. It's flashing now. So it started flashing. There you go, that's the main supply for the ICs, it must be. Yeah, there must be the 5 volt rail, that one. Yeah, okay. So there it's dipping, and that's at 7 volts, 6 volts, it's flashing, 5 volts, no good. Too low. You can see it just locks up, and you can actually look. It shows the voltage level on the display there. It's pretty interesting, isn't it? Well, it's obviously just locked up. It's 2 volts there, 3 volts, 4 volts, 5 volts, 6 volts, 7 volts starts working again, just 8 is working. So it looks like it may be the 5 volt rail or something like that. That one's supplying. So if I stick that at say 9 volts, and that's drawing 800 milliamps at 9 volts. So between 6 volts and 7 volts the current drops right off. So it does need 7 volts at least, 8 volts is 800 milliamps. Yeah, it needs 9 volts minimum, I would say. Really? Yeah, it seems to be shutting off at 6. 6 the current drops down quite a bit. Really should be changing this view or something, shouldn't I? But okay, let's go up a bit more. 6.5 it starts coming on. 6.8 is 0.2. 7 volts, 300 milliamps. 7 point. I think it needs about 7.5 volts minimum, really. Okay, so I might call it an 8 volt supply. Really, it needs what it needs. So that's at 7.6. It starts flashing there. 7.6 volts with the other supply at 13. So shut the other supply down. Put that one down to 10. Or should I do 8 as well? I wonder if I run above an 8 volt supply, would be nice. So that's flash at 7.6. Yeah, so 7.7 is okay. Alright. So running both from 8 volts. I don't know, is that okay or not? Seems to be alright. Is it accurate? Don't know. Not see much difference between that and that. If you hold the SPO button down, then you get a SPO readout. And it's given a constant value. I'll get it to do it. There you go. Now it's definitely not 107 dB in here. So I think this microphone is knackered. I'm pretty sure that's wrong. There's definitely not 100 dB of noise in this room. Be lucky if it's 70. Yes, there's lots of gibberish on here. I think it's because of this microphone. You take that away, it all goes away. So I think this is knackered. I'll have to get another suitable microphone for it. Which is a shame because these are, you know, fair value. Right, so it looks like that's both supplies running for 8 volts and it's okay there. Well, if I have a margin here and make them both 9 volts, can I strap the supplies together? I wonder. I wonder if they can both be the same voltage and still be okay. At 9 volts, it's 860 milliamps and 260 milliamps or so, which will probably change with the number of LEDs that's on. For one that gain right up, I'll give most of them on. I talk quite loudly. Yeah, that's running the LEDs, so that's like 300 milliamps. But that is working. So, if I don't know, can I strap those supplies together? Let's have a look and see if I want to have one supply. Because that's ultimately what I want to achieve. But then if I strap them together, does that mean it's going to then run 2 high voltage into one then the other? There you go, it's drawing 1 amp at 9 volts of a single supply. Well, it still seems to be doing stuff. So that the lighting being in the way, but so I'll turn it off. Oh look, it's still on. But obviously the power switch is on the AC side, so it doesn't matter. Now this is what I'm wondering about, this whole link thing in the back there, where the battery pack used to be in it. And this is puzzling me now. There's that link on the back I'm suspicious of. Let's do some measurements on that. Maybe that's where the battery should be connected rather than onto this jumper here. Maybe that's what it should be. I don't know, because I'm only guessing. I don't actually know. Stick it on the ground over here on the power supply. And measure down here. Oh, I'll take the probe off too. Nothing there. Both sides just in case, nothing there. Not relative to ground at least. If I do relative to positive, nothing there either. So I don't know what that does. It's not a ground, it's not a positive. So what is it? I don't want to pull the board out and trace it, that would be a real pain. I might have to if I really want to understand what it does. Alright, so I decided I'm going to pull this board out, I'm going to have a look, because this is going to drive me nuts otherwise. I really just need to know. So it's, I've already put one connector off. I have to be careful which way these go. So I've got a black wire towards that end of, well, this end of that one there. Actually, if I mark it, it might be a better idea. And I can't get it wrong. Like that. And like that. Go together, it should be alright. Let's try and pop this one out. I've already taken the screws out, but I can't actually move it yet. I'm really hoping I don't damage something in the process of trying to get something apart. That's never a good thing. There we go, that's that one off. Let's get this bit hot glue just there, which is okay. Move that out of the way. Hopefully my head's not in the way of this bloody video recording. I'm having to lean over things to see what you're doing. We'll get this board out first. Some of these things are obvious where they go. They can only go in one place. That's quite loose, that one actually. That's really loose on there. Try and pop this one out as well. Usually, once you get them moving, they're usually okay. You have to get them started usually. Come on. Okay. Set on there. So I think that's all the wires off, apart from the front edge. So there's a panel under there, aluminium panel, which has got some adjustments through it. I need to take the screen out, I think. Although I might be able to take the whole front panel off now. Maybe. Oh, it's got some through-hole stuff there, which is going to be attached to the bottom panel. This isn't going to be easy to get apart, is it? I think taking the LED display off isn't really going to help much. The aluminium panel's got to come out. I think that's what I'll have to do next, get the aluminium panel out. Then as I get back screws out, then I think I can lift the whole lot out as one unit, like the front piece and that board. I think I can't see where the screws are on that front panel there on that section. Right, this is going to be tricky, but it is what it is. I have to be really careful with these wires. That one's okay. I've got this which wraps around the earth wire for some reason. Anyway, that can be unplugged. That can be unplugged. So I'm just trying to see. I can probably get that board out in itself once I get it all unmounted. This is about getting a spanner for these standoffs. So I've started taking things off. I've already got one pair of standoffs off, the two front ones. I've taken off the power plug here, which goes to the main board down there. This power plug here off the main board, disconnected. So the main board's not plugged into anything now. I've also got to get this all out the way and get the screws out of this bottom plate so I can actually get the board out. I'm having to use a adjustable spanner because the size of the standoffs is not 6mm, it's not 7mm. It's in between the two. It's probably about 6.2mm or something, I guess, but so I'm going to use a little adjustable spanner, which is why I've got it, because it's good for little things like that. Try and show it I'm getting off there. Yeah, so standoffs in there. Also, got to try and be careful not to damage any wiring and stuff like that. But yeah, it's a bit tricky, but not too bad. It's not the hardest thing I've pulled apart. I might have to take that front panel assembly off actually. I'll have to take the board out with the assembly, I think, actually, when yeah. So that's got to come out. So let's get those out. That's got to come off too, that's a bit of a shame. So that's that part, that moves around. So it's actually looking fairly promising. That wants to pick up and move. So let's get these screws out the board here. I think I'm still going to take the standoffs off though. Go through that board. I'm pretty sure they're attached to the casing, not to something else. Yeah, it's definitely attached there. That's okay. So, get the aluminium plate out of there. And there's all the attachments to the front panel. As expected. Yep, so standard's got to come out. That's what I thought. It's already loose. Sorry about the view of the camera, I'm probably in the way. It's already loose. So a couple of these weren't even that tight to start with. Mind you, 20 odd years of thermal expansion probably does that, doesn't it? Right, It's got star washers everywhere, which is quite nice. Until you lose them, of course. And then you have to figuring out where the hell they all are. Nearly there. Nearly there. I think once I get these two standoffs out, I should be able to get the board out. And I can actually try and understand the circuitry then. Just want to figure out this power supply section and why they've done it the way they've done it. It will have a boost converter built into it because of the 48 volt phantom power that's required for the microphone. So, here we go, it's moving. This out of the way. Now we can try and reverse engineer what the hell's going on in here. Okay, so the main thing I'm looking at is that wire that's got a jumper across here. So there's a trace. Empty hole. Nothing there. It goes across there and there. Empty holes. Doesn't do anything. You can see it's been resoldered at some point. Or reworked maybe. A bit of flux around. Yeah, this has been resoldered. Someone's done some work on this in the past. Something I have actually done is I've done an audio sweep. I've plugged the waveform generator on my Agilent scope into the front panel of this. I've got to use the Keysight one, but much muchness, both work the same way. Plugged it into the front panel of one of these inputs and swept the audio range, just manually gone through, and in the levels on that section was the same all the way across. It was exactly the same. The same LED level across all of them. So that audio input, based on a artificial injection, is accurate. You know, relative to each other, they're exactly the same. So I'm not worried about any stages not actually working properly or anything like that. But I'm worried that the microphone doesn't work properly. Anyway, let's just have a little look around here. My head's probably going to get in the way from time to time while I'm looking. I mean, lots of rework's been done on this. Probably what those standoffs were loose. But the fact there's a jumper on those two pins there, and nothing actually on the other end of those connections, that's a bit of a joke, isn't it? So that answers that question. That jumper wire does nothing. So maybe that is for the battery pack thing, but even though on the back of the unit the battery pack is ticked as an option, so maybe it's never actually had the battery pack installed, because it doesn't have a battery pack header on here. I don't know. I mean, I think that is the battery pack connections. I'm sure of that. But the fact that it's got this, you know, all this interconnect here, it's just really interesting. Alright, so let's reverse engineer the power supply section just here and just try and figure out what's actually going on there. Obviously there's going to be charged circuitry and stuff like that. So let's see what I can actually work out. So we have a voltage regulator here. If I pop the... Oh, it's glued on, I'll leave it alone. There's a lot of solder on the side of it. Yeah. Well, that's not good. Get rid of that. So we've got a ground there which goes to that point. I'm just trying to trace it through, which is a jumper wire, which then goes down to the main ground track here. Yep, star grounding. Just there, you can see a star ground point right there, as you'd expect on a piece of audio gear. So that's definitely neutral, well the ground, sorry, neutral, 0 volt rail. Those two there, what are they doing? One goes to that point. One's going across capacitor. So I'm looking at these pairs of wires now, right? These junction pairs. So one's going down to there, jumpers across. There's a capacitor across here. There's something here. something here, something there. So let's just follow those through and see where they go. That's another jumper wire back up. So let's jump a wire back up to there, which goes to that pin. So yeah, definitely straight in parallel with each other. Okay, so now let's look down what's going on down here, which is a ceramic capacitor, obviously for noise suppression, and then it goes to a jumper wire which goes over here. Right, so that's this track I'm talking about right here. Ceramic capacitor across there, jumper wire across there, comes to this point here, which is part of the diode bridge rectifier. Okay, so it's rectifier output right there. So if I follow the other side, so that is also the main supply coming in from a pair of diodes. Yep, that parallel pair, so it's pulling, which connections are those? So that's those two terminals there, which were the orange, I think, which is a black and an orange. So that is 15 volts AC. Okay, which then ends up, you can convert that to AC. Single phase AC is going to turn into 18 volts DC. Okay, that kind of makes sense. So where does the other one go to? The other one goes to there, which is, let's try and trace his other side back. What's that one doing? This might be different. It's got a jumper pin. Jumper pin from one side to the other. Yep, okay, so that's the main rail down here. I'll point that out. So there's the other pair I'm looking at right there. There's a jumper wire from that side to that side, so they're linked together. Comes down here to here, which will be another jumper wire. To make sure, yes it is. Jumper wire down to here. That's another capacitor. That's grounding. So that's back to the style grounding again. So that's also the smoothing cap. Back down to here. Other side of the diode bridge, which is the 30 volt side. Is that right? Nicer blue ones. So that's the 10 volt rail. And it's also got, what, there? Ceramic cap as well on that side. So there's also a ceramic capacitor across here. So it comes down to here. That connection there is the ceramic capacitor. Diode bridge, positive side out from both of those rails there, which are those two there, which are the two blue ones. So that's the two blue ones in parallel to increase the current and give smoother signal. So that would be 12 volts DC, ends up getting converted into, yeah, that's okay, that makes sense. Ground is linked together as I suspected on the board, so the two 0 volt rails are linked there and there. So yep, that's what I thought as well. Which I'll just note down here so I don't forget about it. So that and that. I am obviously missing something. Ah, what's that connection there? Where's that go? That's a horizontal jumper, that's right. Hold on. Here we go. There's a connection there. It goes across. There to there. Right. There's a jumper, which then goes that way, which then powers more capacitors. Comes down to here. Snakes its way around down to there. There's a resistor. There's a IC there it's feeding. BA456A, whatever that is. So my interpretation of this is that this pair here, which go straight from that pair of diodes to that socket, doesn't seem to go anywhere else. I'm going to double check that and make sure I haven't missed anything. There's a jumper there. There's a jumper there. Why is there a jumper when it's got a track that could come straight to it? It goes to there. Oh yeah, I'm missing stuff anyway. God, I'm missing stuff. I missed all this stuff. So there's a 4-pin connector here. and it comes down to here as well, which is another jumper wire, which then comes down over here somewhere. What's that 4-pin? Those are tantalum capacitors, and that's a ground, so that's input to voltage regulator, I'm guessing. Of course, the tantalum there, where does that go? Because I was thinking that one side could be a charged circuit, one side could be the supply. Yeah, okay, so the fact that the voltage regulator means that that input voltage is not that critical. So is it doing a comparison between those two voltages in order to determine when it's running low? Is that what it's doing? They both drop down to a certain level. Because it was at 8, was it 7.6 volts or something? It's tripping out. So 8 volts would be a threshold there. Maybe it's got an 8 volt regulator, and it's comparing that. Once that 8 volts drops down as well as the other one, maybe. I don't know. I'm speculating. So we've got another regulator right there, and I think there's all that boost circuitry and stuff around there too, which will go over to the phantom power, which is over here. Can I trace in it back? That's soldering is not the best on it. It's like it might have been repaired at some point. My evidence on the board of it being repaired at some point, so I don't know. I don't trust them to be correct when you see blobs of solder across pins. I mean, is it meant to be like that or not? I can only see one connection to each group, so maybe it's okay. There's a jumper down to there. So both sides do come over here. That regulator up there, it does use 2 supplies, which I'm really surprised about. Maybe it's for isolation. Audio circuitry versus digital circuitry. Maybe. A circuit diagram would be wonderful, because I really could use it. Dual supplies is weird. So look at the AC side now, because I'm thinking I still need to do that conversion on this thing to make it 240 volts instead of 120 volt. So now looking at the other section there, which is that neutral comes into the N pin, which goes to there, which is linked onto those other 2 pins. Hold on a minute, this is American made, isn't it? I'm thinking it's backwards. That isn't neutral, is it? That's phase. It is. I'm forgetting it because Americans use different colour coding, right? So black is phase in America, I believe. I think I've got it right. Correct me if I'm wrong. And look on there, yep, live is on that pin. I'm thinking this one is neutral. It's not. The neutral is going to the transformer. I thought it was a bit weird. It's back to front like that. So yeah, phase goes down to there, onto the connector, up the trace PCB, through the switch, back through the fuse, back to that side, which is the other side of the transformer. So yeah, that's the switching the primary on transformer on. Goes in, through the switch, through the fuse, back out to the transformer. Yeah, that's fine. That's exactly what you expect it to do. So this DC side is just weird with the dual supplies. At least I know what voltage I can use, which means I can make a battery pack up for it. And I know that as long as I've got more than, well, this one, as long as it's low, I'll make that 7.6 volts, not that. 7.6 more seem to be the more accurate voltage. I think it will run okay, both on 9 volts. Which makes you wonder why it's dual supply. I mean, you don't need dual supply. Circuit diagram would be really, really good. I mean, sure, I can figure it out, but it's got some weird stuff going on here. It doesn't require dual supply. It must be purely for isolation. It just must be. Well, the main thing is I know what voltages I can use, and it means I probably need to have a dual battery pack in order to keep the isolation, but it may not matter. It seemed to be okay without the isolation there. But if I isolate the battery packs, it'd probably be a good idea. Have a dual battery pack to 9 volts or something. I can even have 2 12 volt packs, can't I? Because that's 12 volt anyway, normally. But I also need to consider charge circuitry. I need to think about how I'm going to charge these batteries up. And they need to be able to supply an amp. I've got to think about that aspect. How to charge it. How to set these voltages above 8 volts minimum. I'd say 9 volts minimum, give it some headroom. Although I haven't checked the phantom power, have I? Maybe I should check the phantom power to see if that drops off at a different voltage. It might be why it needs a dual supplies to run the phantom power. It's quite likely, actually. Oh, so we're looking at this circuitry here, trying to figure out how this is wired up for the battery originally, and how it switch it on and off and that sort of stuff, because obviously having power going straight here means you can't switch the thing on and off anymore. Also intrigued by the fact there's a link on this connector here. I think I've figured it out. Now, normally this plug is, well in this case, this plugs in this way around, right? So this wire here is switching the main supply. And those, obviously those other two pins there, they loop around and go to these unpopulated pins there on the header. There's no header pins in there for it. So, but if you take this plug, take it off, turn it around like this, put it back on. Now that link is holding the mains power on all the time, and this switch is now running across those two unpopulated header pins. So I think if this had a battery pack installed, there's two more pins here in the header which go to that adapter. Now the other interesting thing was got those double pins here, you know, both connected together. Well, looking more closely at the jumpers, if I get something to point with, yes I do. You've got JP2 which is marked and JP3 which is marked. The fact that those two jumpers are marked and none of the other ones are means they're probably significant. Let's try and get the light off here so you can see a bit better. JP3 is the leftmost one in that set of three, and JP2 is here. I haven't found a JP1, I'm not quite sure what that is, but those are what's linking those pins together. So JP2 is linking those two pins, JP3 is linking those two pins. If those jumpers are cut, which looks like it's probably been done before because they've been soldered back together, then it isolates those two pins, and then one pin is in from the supply and the other pin is out to the circuitry. So they're in series with that circuit. So if you cut those jumpers, then you do have an in and out on each supply rail at that point. And having this connector turn around this way means you've got the switch supply on those two pins. The interesting thing is this, the case on this thing was marked saying it had a battery backup, well, a battery pack installed. And those have been cut, which makes you think that, yeah, that has probably been uninstalled, but there's no header pins, which is the interesting part about this. That's what kind of throws it all out, because without those in there you can't switch the thing on and off. It doesn't quite make sense. So I don't know why there's a bit of inaccuracy there, but maybe there's a way they did it. Maybe these wires didn't go to here anymore, maybe they went somewhere else. Maybe they went straight to the battery pack, or maybe the battery pack had a connector like this on it and you put that onto the battery pack instead. I mean, that's possible. I haven't found any pictures of the battery pack or how it's installed or anything of the inside at all anywhere. I've been looking, I haven't found anything. It's just from what I can surmise from looking at the circuitry. So what I'm going to do, I'm going to install a pair of header pins in here before I put this back into the case. So I've got the headers there ready to go, and I am going to convert this to run as a battery pack. Now obviously I need that weird thing with the different voltages, you know, that 7.6 minimum and 11.4 minimum, but obviously 12 volts and 18 volts are okay. But these voltages must be high enough to be able to charge a battery pack when it's installed. The thing is though, is this one here higher, because that's what's doing the charging. Get it in shot, sorry. There you go, 18. Right, if that one is higher, then that could be one that's doing the charging circuit, and that's just an outlet, an output from the board. Maybe. But the fact that they're in series rather than just having a 18 volt supply going nowhere on that pin means it's obviously used. I mean, the test then it was using it. So that doesn't quite hold up. So I'm not quite sure why there's those two supplies still, and that's the only bit I'm still not sure of. It could be that that is required for the phantom power. I'm going to play around with that when I put it back together, and I'll try and see if that's what the case is there with that. But yeah, so I'm going to put those headers in there and carry on. But I still need to get a battery pack of some kind, and maybe make a little circuit board up which will interface to this, but then use those two pins here for the switching. A double pole relay or a couple of relays on there or something like that instead, which will do the switching on and off of the circuitry through those pins there. I think that's what it needs to do. Record me installing this. It's got a solder bridge across the back of the holes already, so I'm just going to solder those in as they are. Come on, work your way through the holes. Thing is, it's done look like they've been soldered before, which is the interesting thing. I mean, it said it had a battery pack in it once, but it doesn't really make sense, because otherwise these pins would have been in there. It's hot glue's in the way. Just got to get out of the way. But there you can see is that little lump of solder on there, so that's actually been bridged back together at some point. So I believe it has had a battery pack. It's just a lack of header pins in these two holes. Surprises me, you know. So it must have been that there was a plug like this on the battery board, and that plugged into the battery board instead, and that did it all that way instead of going backwards and forwards. That's what I can think of. Maybe it's a circuit revision or something, I don't know. But so these headers aren't quite exactly the same. So I'll try and get these lined up so I can use the same thing to actually make it work. Must just be rubbing on the plastic there. Just trim it back a bit. Yeah, it's better. I'll probably get away with that. Okay. Where's my solder gone? There it is. Okay, that looks like it's about right. Done. So that's just preparation when I do go to put the battery pack in. There. Right. So I think they're pretty much lined up. I mean, they're close. They're pretty much there. Anyway, that'll be right. So at least I've figured out how this thing goes now. So we'll just plug that in like that, the thing will be on all the time. At least that's an easy change. So anything I'm going to do is going to be easy to do. My cat seems to be wanting to get on the act. Stop complaining. Bippy, go away. Right.